Okay, here we are at Desmos. What we're going to try to do is estimate the partial derivatives with respect to x and y at the blue dot, which I'm calling P, and estimate the partial derivatives with respect to x and y at the black dot, which I'm calling Q. Let's do the partial derivative with respect to x first. Remember, doing partial derivatives with respect to x, what you're trying to do is walk from west to east. And when you get at that point, you want to know what the slope of the tangent line of the travel would be. One thing that it's good to know, I think, is that the color over here, these are actually positive z-values. These are positive z-values. The ones up here are negative. The ones down here are negative. So when I walk from, let's just draw the trip. Yes, as I walk from west to east, you can see that I go down and then I go back up. So I can at least think G is positive. Now what I want to do is just have some points where I can just calculate the slope. So I picked a point to the right of the blue dot and a point to the left of the blue dot, and I just estimated their x values. This looks something like 2.1. This looks like something like 1.6. Maybe so I'm thinking from here to here is about 0.5. So if you come way over to here, you can see that I'm calculating fx. So it's delta z over delta x. You can see that's 2 over 0.5, and I think that's about 4. So I'm thinking the slope of the tangent line as I walk from west to east here would be about 4. Now what I'm going to do is turn off those points, and I now want to go for a south-north trip. And let's move that over. You go like this. And again, I think here, these are negative, so I think these are getting bigger and bigger and bigger, and then smaller and smaller and smaller, so I'm thinking I'm going to get a negative number there. Again, what we always want to do, if possible, we want to pick a number. Try not to find the slope of the tangent line at that point. Use a point ahead of it and a point before it. I've got some points here that I think I can turn on. Yeah, so all I want is the delta z. Notice that the change in the z's are always here because they're just go up by 1. You can see that they go up by 1. So for example, this is 4, this is 3, this is 2. So all I want to do is take the z value here, the z value here, and divide by the change in the y value. The y value over here looks like about, I don't know, 1.6. The y value here looks like, I don't know, about 0.6, maybe 0.8. So I'm thinking that the change in the y from PL to PU is about 0.8. The change of the z value is 2. So if you come over here, you can see that I'm calculating it, where you can see delta z over delta y going from PL to PU is about negative 2.5. We knew it was going to be negative anyways, but we get that. All right, now let's approximate the partial derivatives over at Q, the black dot. So let's turn off anything that has to do with P. How about that? And that. Yay, it's all gone. Now what I want to do is estimate the slope of the tangent line at the black dot Q as I go from west to east. In order to do that, I want a west to east trip. So I'm going to turn on my west to east tripper, and I'm just going to try to move it up there. And so you see that what I'm going to try to do is walk along that line. Now you're going from positive z-values to negative z-values to higher negative z-values to positive z-values. I'm thinking I'm going down at that point. I do have 2 points, just one to the left and one to the right. There I think I can turn on. Yay, there's my points. So what I want to do is just take delta z from the left dot here to the right dot here. The delta z should just be, I think, negative 2. The distance looks like, if you actually just go way down here, you can see that the distance, horizontal distance from the left dot to the right dot is all 0.6. And you can see over here I'm calculating that the delta z over delta x is about negative 3.3. So it's pretty steep going down right there. Now let's do our last one. What we want to do is go on a south-north trip through that dot. So I'm going to go turn off my west-east, turn on my south-north. Let's bring it over there, have it go through the dot if I can help it. A little bit more there, almost. Yay! Okay, now again, oh boy. Here we go. No, a little higher. There we go. What I want is to go on a south-north trip. I can see that the z values are negative, then positive, then negative again. So I'm thinking the slope's going to be negative. I want a point just past it and a point just before it. I think I have some points there that'll do that for me. I get that and that. I want the delta z from the lower point to the upper point because I'm headed north. The delta z should be -2 because you can see that the z values are becoming more negative. I also want the change in the y value. Well, if I walk over here, you can see that the change in the y value is about 1/2. And so what you're going to get down here is that as I walk from south to north along this, and I estimate the slope of the tangent line, there's going to be delta z over delta y, you're going to see that you're going to get -4. So that's our estimates for finding the slopes of tangent lines for 2 different points on the saddle.